Bitcoin CLI. We're going to start from the beginning now that everything is fixed here. And we're going to take a look at the first command to see if everything is working. So we're going to do Bitcoin CLI, and then we're going to do get block hash, like that. Or not get block hash. We're going to do get blockchain info, like that. All right, so if you have that and your node's running, then you should be good to go, and you should be seeing all of these different things. Now, I don't know what every single one of these means, but I have a good idea of like what a few of them mean. We could probably look it up actually in the API doc. So like if we go and see get blockchain info, I know it's under Bitcoin Core, so okay, here we go. This is their developer thing. Yeah, so you can see this is what each one of them actually stands for, right? So like the chain, it's pretty self-explanatory. You're on the main chain, not like a testnet or something like that. Blocks, this is just the height, or height just means how many blocks are in the blockchain. I don't know what headers is. The current number of headers we have validated, I don't know what that means. The hash of the currently best block, I'm sure, I guess. Current difficulty, you can see. Now the other one too, verification process, because this one confused me at first, because I was like, okay, is this out of 100 or is this out of 1? And it's actually out of 1. So when you are very, very close to 1, approaching 1, then you basically have the entire blockchain downloaded. And then there's size on disk too, which is in bytes. So, you know, this is basically, you can just cut it off there and it'll be in gigabytes. So this is about 445 gigabytes on my disk right now. I'm also using a pre-release test build. So I'm not using like an official release. So that's why I'm getting this warning down here as well. Because when I pulled down Bitcoin D, I just kind of installed what was there. I didn't like check out a release version or anything like that. Let me remove this because we don't need that. All right, so I'm gonna move this up here. I'm gonna move this around like this. Yeah, I don't know. I haven't really used DuckDuckGo. I've been using Brave's new browser thing. But I'm going to probably be taking a look in the future at something called impervious.ai. Impervious.ai. And so they're supposed to launch during the Bitcoin conference. I requested early access. They didn't give it to me. But yeah, they're going to be, I think they're like a layer 3 on top. Yeah, see? So Bitcoin, layer 2 Lightning, and layer 3 Impervious. So I am looking forward to this because it's got streaming payments for video, audio, and content streams. That's crazy, right? Like if this actually works the way that I hope it will work. And censorship and surveillance resistance. So you have all encrypted messaging and payments. And then I think they have some sort of like built-in VPN. Probably they do stuff via the Tor network, because I know Tor is like kind of hand in hand with the Lightning network. So yeah, I mean, I don't know, man. This could be like a game changer, this browser. This is the one I want to switch to. So, but it's not out yet, as far as I know. You might be able to build it or something, but I haven't. I'm going to wait until they release it officially. Yeah, I don't know what the speed will be compared to Tor. I'm assuming they have built-in Tor. But yeah, I'm very much looking forward to that. Okay, so get info. What did we do? We did get blockchain info. And so that just gave us some basic info about our stuff. The next thing we're going to do is we're going to just take a look at Bitcoin CLI help, like that. And when you do that, you can see all the different commands that are available to you. All right, and now what we're going to do, and I'm basically, if you're watching the stream from the future, I am in the chapter 3 in Mastering Bitcoin. So you can look up Mastering Bitcoin. It's free online, and you can kind of just, you know, read through the docs here. And I'm just going to be going through the docs. I got the book in front of me, and I have the docs up here just in case I need to like copy and paste something or whatever. This is kind of the first chapter that really like matters. All the chapters before this one and kind of exploring the blockchain and running Bitcoin Core. I didn't really set up everything, like show everybody how to like install all I think I have an old stream where I showed you how to install Bitcoin Core and stuff. But once you have Bitcoin Core installed and accessible somehow, then you can follow along with, you know, running commands and things like that. And I feel like you can't really read this book without having your own node set up. Like there's no reason, like it just won't stick because you won't be running the commands and stuff. So, all right, let me really quick. Okay. So now what we're going to do is we're going to do the next thing in the book where they go and get a raw transaction. So yeah, so to get that transaction, we're actually going to go and grab it from here. Get where it is. This is get blockchain info. If you're reading the second edition of the book, then this is get info, and then it doesn't work. Oh yeah, and the next thing I'll show is actually this. So if we do that and we do bitcoin-cli help get block hash, we can actually zoom in on the help for all of these different things. So, you know, you can see extra help for a particular thing, and then also you can actually run this as a curl command as well. So really, this is all just wrappers essentially around just JSON RPC calls to your Bitcoin node. So anyway, yeah. So returns a hash of the block in best blockchain at height provided. So height is really just the block. Like if I say that if I pass it a height of 1,000, that just means the 1,000th block mined. All right. So now let's do bitcoin-cli and then get block hash and 1,000. There we go. And so this is the 1,000th blockchain mine, or the 1,000th block in the blockchain mined, and this is the hash for that. Yeah, I don't know. Are GPUs any better now? I haven't tried to buy a GPU lately. Also, I have an electrical engineering degree, and honestly, I don't know. I don't know if it was even necessarily worth it. There's a lot more money in just software at this point. And it's a lot easier. So, getting an engineering degree was a pain. So, let's see. Bitcoin-cli, get raw transaction. That's the next thing we're going to do. But we don't have a transaction. So, like, what I did was, when I was reading the book, I thought, like, this was the I don't know why I thought this was the transaction. But it just kind of threw me off because I like couldn't find it in the, like the blockchain couldn't find it. Like for instance, like if I did Bitcoin CLI and then get raw transaction, and then if I paste that, whoops. And if you paste this here, this is just a block hash, right? And so like I thought this was the transaction. I have no idea why. But that's why I couldn't find it. If anyone else is dumb enough to make that mistake, I don't know. But yeah, so did that. Here's another one, get network info, but we're going to try and get this transaction. So, and then we'll take a look at the get network info. Oh, that's where that new line came from earlier. Okay. So we'll just copy and paste. No, actually I'm going to grab the whole command so I don't have to type it out. I press Control-Shift-C because I'm used to copying from terminals. All right, and we're just gonna get rid of this new line, like this. All right, so now with get raw transaction, what we get back is a just a big serialized hexadecimal number, and this actually represents some JSON. So we'll do this. Whoops. Control-Shift-C in the terminal. All right, so now we're going to do Bitcoin CLI decode raw transaction There we go. And you can see that it's really just a big serialized JSON hexadecimal string. That's all that was. And so this has a transaction ID, a hash, which I guess is the same thing, size, weight, so on and so forth. If you want to know what they are, I recommend going and just like literally looking this stuff up online, and you'll get a better idea of what these things are. I still don't know what everything is, or how it's used. How much time would it take to reverse SHA-256? I don't know. You got an eternity? Do you note things alongside reading books, or just coding along with it is enough for you? I find that I tend to forget some details even if still using it often. When I'm learning this stuff, like, I don't know. I think if I stream it enough and talk about it enough and work on it enough, I don't actually ever really need to take notes. Like, for instance, I don't take notes at work, right? Like, I'm a Java engineer at work, and like I have code snippets, and so what I'll end up doing is I'll likely, like, I won't like save any of this stuff, right? Because this is just these are just Bitcoin CLI commands, which can be useful. Just like, you know, if you're interested in something, you likely know what you're looking for, and then you can just like go look up the correct Bitcoin CLI command to go do it. But basically all of these things they have like bindings in particular languages, right? So like later on, maybe in this stream, I'll go over Python bindings for this. And so what I'll end up doing is just writing like just some quick programs, code snippets, you know, maybe post them to a gist, maybe save them to my blog. Like I've been working on my blog over here, and what I'll end up doing is just you know, putting something on my blog, and then I can just go through and like search through a post or something like that and go click on it, and there you go. Now this is all fake right now. This is fake stuff on my blog right now, but you know, I'll usually do something like that. Like I'll keep a bunch of code on my blog, or I'll keep it somewhere where I can access it. But I don't usually like take notes. I don't know. I think I don't think there's enough data to really break SHA-256 like that. Like I guess with quantum computing, people say, but I don't know anything about quantum computing, and I feel like people just throw that term around. They're like, well, Bitcoin's going to be, you know, obsolete because quantum computing. It's like, bitch, you don't know anything about quantum computing. You know what I mean? Nobody knows shit about quantum computing. So, I don't know. Yeah, I don't know anything about Google programming tutorials, but I don't know. Anyway, hopefully that was helpful. I recommend starting a blog or something, I guess. That might help. Anyway, so we did get raw transaction, but I noticed something new that's not in the book was he did get network info here. Let's see if that returns anything. I mean, we can see what's there, but let's see what we get when we put it in here. I just saw onion. And I don't have an onion router and all that kind of stuff set up. So I also don't know what I2p is, but I just saw that on the impervious.ai thing. What is I2p? I know P2P, right? Like just peer-to-peer. What is I2p though? What is I2p? So this is just learning in real time. Invisible Internet Project, I2p. Interesting. See, there's so much to learn with this stuff. Like, I just didn't even know this was like a thing at all, you know? Welcome to the Invisible Internet. Now I'm on a list just for looking up I2p for a stream. Yeah, you know that they care, right? Because like they have like a GitLab and not a GitHub, and they have like a Mastodon like ahead of their Twitter or something like that. So it's kind of funny. Anyway, this is cool. So Impervious AI uses that. They use P2P. They use that. I just think that there's stuff with streaming payments for video and audio for content streams. That's going to be a game changer, dude, especially if they're like censorship and surveillance resistant. Like, I don't know, man. That's going to be really cool. I2p is alternative to Tor? Okay. I didn't know that. I'd never heard of it. Yeah, it's again, like if you have a SHA-256 collision, right? I mean, you have to think like I'm pretty sure I read a thing where they're like, okay, if you took every possible like hash in SHA-256, it would like fill up like basically every atom in like the known universe, right? So like for you to get a collision, you'd need to like pick two atoms. You know what I mean? You need to pick the same atom twice potentially, I guess. You know, like you have all these options and you'd have to pick it twice. There's a really good like explanation for how difficult it would like it's just the incomprehensibility of large numbers. Like there's no way for you, like it's just, the word is not necessarily impossible, but you can use the word infeasible, but that even doesn't do it justice. What device am I mining on? I'm not mining. I'm just this is just my node, right? So you can run a Bitcoin node. You don't have to mine, right? Actually, most people who are running Bitcoin nodes aren't mining, right? Hash power is really for the people who have hash power, you know? I mean, I could sit here and try to win the lottery, but it's really a lot more like winning the lottery if you're not one of them. Anyway, so you can see protocol version. I don't know what this is, subversion here. Satoshi 2299.0. But yeah, this is some network stuff. I don't know who uses IPv6. I know I don't have Onion stuff set up, but I know you can set up Tor. I2p, this was the first time I ever heard of I2p. I also don't know what CJ DNS is. These are relay fees. Is that can't be like a Lightning relay fee. So it's got to be like I don't know. I don't know what a relay fee would necessarily even be. Anyway. So let's move on though. So we did get raw transaction. We decoded that transaction. The next thing we can do is we can get more block hashes. So that's what they're doing in the book. So we're going to do bitcoin-cli. I'm about to alias this. Hold up. Just let's do open our bash RC. Let's learn about aliasing really fast. And we're just going to jump to the bottom and we're going to do alias like this. And then we're going to say BC is equal to bitcoin-cli like that. Okay. And then we're just going to do dot, and then we're going to do dot bash RC like that. And then we're going to do BC. And now that's that. So now we can just do BC instead of bitcoin-cli. Typing that out is just, I'm not going to keep doing that. So we're going to do get block hash. And what they have is 277,316. So this is some height, right? So this is just some block on the network. It's the 277,316th block, I guess. Is that right? Yeah. And so we're going to get the hash for it. And there you go. Why is encryption used for passwords? Well, there's all kinds of reasons to use encryption for passwords, especially if you're storing your password somewhere that potentially other people could see. And then you can keep an offline encryption key. But anyway, so now we did get block hash of that. And so this was just some block. Now in the book, in each block, there's tons of transactions that are included in a particular block. So what we're going to do is we're going to do BC and get block. And yeah, we're going to paste this in. So we're going to get the block for this particular block hash, and we're going to see what comes out. All right. Now, I think this is just a bunch of transactions, like a bunch of transaction hashes. Yeah. So that TX stands for transaction. So these are all the transactions that happened in that block. This was the difficulty at that time, which I think is like half the difficulty, or probably even less than half of the difficulty of what's there today. And for each block, you obviously get the previous block hash, and if it has a next block hash, then you'll get the next block hash. So then you know that this thing is. That's a like you should probably look into like why the Bitcoin network is so secure because of these block hashes. Like people really they look into the cryptography aspect of Bitcoin and they think like it's all encrypted and all that stuff, but it's actually really like all open, and the only stuff that's actually really important, the linked list. So like the fact that basically it's a linked list based on cryptographic hashes that aren't necessarily securing data, but they're securing what's the word for it? I'm trying to think. Like they're securing the integrity of the blockchain more than they're securing like the data in the blockchain, So yeah, so there's all of the transaction hashes. Okay, now we got that. Okay, so now the next thing that they end up doing in the book is writing some Python code. And that'll be a little bit more fun than doing what we're doing right now. Okay, so we are going to need to install a package though, and let's see, it is called not Bitcoin Rpc, it's Bitcoin Lib or something like that. Yeah, Bitcoin Lib. So let's see if we can just install it. Do I have pip? Yeah, I think I do. All right, pip install Bitcoin Lib. Hopefully it's called Bitcoin Lib. All right, that looks like it's working out. Ah, what is that? Did it work? I don't know if it worked. Error, command errored with blah, blah, blah. All right, let's just see if we have it. So we're just going to run Python 3.9. That's good. But we're going to do from bitcoin dot rpc import raw proxy, like that. Okay, that worked. So I guess it didn't care. That's fine. All right, so let's actually write our script then. We're going to, I don't know, let's just go into, I have a directory called repos in here. You can make that if you don't have it. You can just write this anywhere. We can just write it in the home directory for now. It's no problem. So you can just type cd, go home, and then just write it wherever. So there's no special place to put this script. So we're going to do, we're going to call it Rpc Example. So this is how we can essentially, interact with the blockchain without using something like bitcoin-cli. So we do from bitcoin.rpc import raw proxy, like that. And what is it complaining about? Could not be resolved. That's weird because I feel like it should be able to be resolved. Unless I spelled it wrong. I did spell it wrong. Bitcoin dot. Alright, see now you can see that I have all of the methods that it has on it. So these methods all belong to Bitcoin, what comes in with Bitcoin. And so we're interested in RPC because remember the way that we were talking to the blockchain earlier with Bitcoin CLI was through JSON RPC. Have you finished reading Mastering BTC yet? No, dude, I'm in like chapter 3. So no, I got caught up with a few other things lately, like upgrading to DWM 6.3, and then also I've been, like I said earlier, I've been rewriting my blog so that I can post all of these things as blog posts, and then I want to put my videos and stuff like that out there as well. So this is going to be my new website where I do all that stuff on. So that's where I'm at. So if you want to catch up with me real quick, you can follow along and hopefully even teach me something. Because it's not like I like know very little about Bitcoin right now. I'm just going to learn it, you know, hopefully most days when I can stream, just on stream. So let's see, P equals raw proxy. Okay, and parentheses like that. And now what we're going to do is info is equal to p dot get. Now this is probably broken because it's like get info or whatever, but for us it probably won't work. So we're going to do get info, but I'm almost positive that's not going to work, and we're going to have to come back in here and do this. Yeah. Okay. So now we're going to do print info. Yeah, like this definitely is not going to work. And then we're going to do blocks like that. And yeah, that's about it. So now what we'll do is we'll just open up a terminal here and we'll do Python Rpc Example. And now you can see the problem is that if you're following along with the actual book, the method is not found. See that? JSON RPC error message method not found. So what we want to do is instead of get info, we're going to do get blockchain info like that. And we're going to do this again. And now you can see that actually works. So that's because the API has changed since the second edition of the book. Now blocks is actually a thing. So like you can see that if we do BC, actually I'm not even sure, is that going to work? Yeah. Okay, so BC, and then if we do get blockchain info like that, we're actually grabbing this. So we can grab other things. Like I'll show you, like if I put in difficulty, right? So if I go, what do we got here? What's the problem? Okay, there we go. So now if I put in difficulty like this, and then I reopen this, oops, and I rerun the Python script, you can see that I get that exact same difficulty, right? So that's where that's coming from. All right. Next thing. Retrieving transaction, iterating its outputs. Okay, that could be interesting. So now we're just going to save the script, and like I said, I think earlier in the stream was like, this is how I will end up saving things so that in the future I can reference them, right? So this is something, I don't know how often I'm going to be using something like this, but I don't really know enough about Bitcoin to actually know it's useful yet. So this is something potentially I could use in the future. Okay, so now what I'm going to do is I'm going to create another script, and we're going to call this one RPC transaction. So we're going to do mvim RPC underscore transaction like that, and .py. All right. So it looks like it's going to be the exact same thing. So actually, let's grab this line from the other one, and we'll paste it in here, and also this line as well. Okay. And now what we're going to do is we're going to get a transaction ID, and this transaction ID is from earlier in the Mastering Bitcoin book. So basically, if we go down here, I don't know if they even have the same code anymore. I wonder if they do. Yeah, so they have this transaction.py example there. Basically, you can see they're retrieving Alice's transaction from earlier in the book, and basically Alice just bought like a cup of coffee or something like that. So Alice's transaction had one output paying Bob's Cafe, and then you have to understand too that the way that Bitcoin works, you can see that when we finish this, there's going to be two outputs. So there is one output, and this was the payment for the coffee. Then there's what she got back, right? Because the way that Bitcoin works is through UTXO. So the extended, or yeah, I actually forget what it stands for. I know it stands for transaction output, UTXO. So I don't know what the U stands for, but TX is for transaction and O is for output. And so you can also actually notice, like if you remember, like if you were reading the book earlier, you'll notice that actually she lost another like 0.0 0.0005 BTC, and that was sent to a miner. So in the UTXO, I don't know if you actually see what's sent to the miner in the UTXO. I don't think you do. But what you'll end up seeing is the payment to the person, and then you'll end up seeing a payment back to yourself. So what happens with Bitcoin is when you pay someone, you say, okay, I have an unspent transaction. That's what the U stands for. It stands for unspent. And so I have an unspent transaction output. I'm going to spend that. And I'm going to spend that by sending it to someone else. I'm going to send them what I meant to send them. And then actually what I'm going to do is I'm going to generate an entirely new private key and public address just for obfuscation reasons. And then I'm going to pay back myself. And this is another law of large numbers where it's like, there's so many addresses available in SHA-256 that it's no problem to regenerate yourself a new private key and new public key every single time. So if you've ever used something like a ledger or something like that, like you've probably noticed that every single time that you're retrieving Bitcoin or something, the address changes. So that's why that is. It's just for obfuscation reasons. It doesn't actually make it private. But it definitely secures it and obfuscates your transactions a little bit more. Anyway, that's why writing a book about the API of something is hard. It keeps changing every time, even the stable ones. Yeah, it is hard. And that's the thing. Like, you just gotta, like, but the concepts don't really change that much though, right? Like, you're still going to be using Bitcoin RPC. You're still going to be interacting with Bitcoin likely for a long time through RPC, right? Like, there's some things that don't change. The API, like you said, though, does change. So, but somebody's got to write the book, right? And it's fine. Like, you go through and you find like, oh, that doesn't work, and then you go and fix it. Anyway, so now what we're going to do is exactly what I guess I just explained, which is that we're going to be taking a look at the outputs of a transaction. So we need a transaction hash or a transaction ID first. So we're going to do txid is equal to, and then we're going to go grab that ID from over here. We can actually go and get that from his code. So it's going to be an rpc transaction.py. And if we go back to code here, and then we do rpc transaction.py, then we can just grab this transaction ID like that. And I didn't paste it. There we go. All right, we'll write the rest out. So now we're going to do raw tx. So remember, we got the raw transaction before, so we already know what the method is. So we're going to do p.get raw transaction like that. And we know that takes in a transaction ID, so we're going to do txid like this, okay? And then what we can actually do is we can be sure that it does what we expected already. So if we go like this, we didn't print anything. So I'll do print raw transaction. There we go. And there's our raw transaction. So now what we're going to do is decode it, and then we're going to grab some of the, remember, decoding it turns it into essentially JSON. In Python, that'll return it as a dictionary, and then you'll be able to access elements of that dictionary, because JSON objects and dictionaries are they're very friendly. They work together very well. What's the book called again? This is like the quintessential like book for learning, like getting started learning Bitcoin, but I'll give you a couple books. So we're going to do Mastering Bitcoin. That's going to be the first one that I'll show you. Okay, and it's this book right here. But make sure you get the second edition at least, right? But really, if you want the stuff that's not broken, you got to go over to Bitcoin book, like that. So you can go over to GitHub, Bitcoin book, and then it'll be under Bitcoin book. Okay, and this will be one that's not broken. I actually think that this is even broken, because I think this is address, not addresses. But we'll see that in a second. Okay, maybe I'll put in a pull request. Maybe someone else hadn't seen it yet. I'd like to put in a pull request if possible. Anyway, so what was I saying? Oh yeah, books. So this book, then there is, if you want another technical book, Programming Bitcoin. This is by Jimmy Song, and he's a very early Bitcoiner, very smart guy, and he'll show you how to write Bitcoin, program Bitcoin from scratch in Python, right? Another thing people really got to get out of their minds is that Bitcoin's not written in C++ or C or whatever. The reference implementation is written in that language, but Bitcoin's not written in any language. It can be written in any language. It doesn't matter. So you can rewrite Bitcoin in Python. The problem with rewriting, like the reason most nodes and things like that use the reference implementation and use Bitcoin Core is because, like, even if they program a bug in, you probably want that bug as well, even, you know. So you want to follow the protocol as closely as possible. So most people are going to use the reference implementation that's written in C++, but you can write your own Bitcoin node in any language. There's no central Bitcoin thing anywhere, and the reference implementation can change in the future. Yeah, hopefully that's helpful. Yeah, on Temple OS, yeah. That'd be a great idea. But anyway, so now we have gotten this far. Let's finish up our script. So we have this raw transaction. Now we're going to do decoded transaction equals p dot long ass name decoded get decoded transaction, like that. Okay, and then we're going to do raw. We're going to pass out the raw transaction, and then we're actually just going to print that out just to prove that we should get a bunch of JSON, or actually what we should get is a Python dictionary. That's what should be printed out. And it broke, and the reason it broke was because method not found, and that's because I typed this wrong, I'm sure. It's not get decoded transaction, it's decode raw transaction. That's what it is. Okay, and yeah, you can see that this is a big dictionary representing a JSON RPC object. Yeah, wait till xlib is the reference implementation. Go do it, man. Go do it. And fight for that to be the reference implementation. Last thing we're going to do is we're just going to loop through the Utxos, right? Like the address outputs. So let's do well, what I'm going to do first, I just have a suspicion that this is wrong. Let's just grab what he's got here. All right. Because if we look here, you see how it says address and not addresses? If we run that, that doesn't work. So now if we go back in here and we do address, there we go. That's what we would expect. Let's see if we can put a PR out really fast for this. So I'm going to do fork. I'm going to fork it to me. I'm going to clone this really fast. Get clone. Blah. CD Bitcoin book. I'm gonna do get checkout flag B fix get, what is it called? What the hell is this thing called? Fix RPC transaction.py. Fix RPC transaction script. Okay. And then it is in, where was it? Code, RPC transaction, and this needs to be just address. like that. Okay, and we do fix. Change addresses to address. Sure. All right, and then what I'm going to do is, where's the thing? There we go. Yep. Create a pull request, and hopefully someone takes a look at that one day. All right. Now what we're going to do is commit message will be added later. Yeah. I don't know. I kind of hate writing commit messages and stuff. But anyway, this is basically that though, now that I fixed it. But let's talk about this code really fast. So we're going to say for output in decoded transaction. What we could do is actually, instead of doing this, we could do just print, print output, just to kind of see it as it goes, right? And so this is, I guess, yeah, this is one output, and this is another output. And so then each one has one address, and they have some other stuff, but the addresses are what matters. And then also the amounts. So I'm assuming that's also what he got. So we're gonna do I and then that. So it's under script pub key, and then you can get the address, and then also he's outputting the value for that address. So this is the how much Bitcoin each one of these addresses will have afterwards. That's the Rpc example transaction. And there we go. That's basically that. And that's a transaction that's already happened. Let's see, there's one more script. What is this one called? Rpc block. Let's just copy and paste this one, because this one's longer. I don't feel like typing, and it's late and I'm tired. So we're gonna do rpc block.py like that, and we do this, and jump back over to here. And we're just gonna go into the code, and we're gonna go into rpc block, and we're gonna grab that and paste it in here. All right, and then we can talk about what's going on with this. So, okay, same deal as always. We just get the raw proxy and all that kind of good stuff. We're specifying a block height, and a block height, remember, is just a particular block in the chain. So block height just means like this is the 277,316,000th block. Get block hash of block with height, blah, blah, blah. Yeah, so we're going to get the hash for that particular block at that height. So basically you said like, okay, a block was mined. What number block was mined? It was this one. Get me the hash for that block, right? And now give me the block information for that block hash. And so actually what we can do before we do all this stuff here is we can go and print out, and we did this stuff earlier in the stream actually. We'll do print block. Rpc block.py. And so this is a block output. And these are just a bunch of transactions. That's all they are. Transaction IDs, I guess. Looks like it gives you a number of transactions. I'm assuming that's what that is. And so we have 419 transactions there. All right, so let's get rid of that and bring this code back in. So yeah, so this is, we're going to say, okay, give me all of the transactions. So this is going to return a big list of transactions. Block value. Okay, so I already kind of have an idea of what's about to happen here. So what's going to happen here is, I'm assuming, is we're going to go transaction by transaction, get the value that was spent in that transaction, add it all up to see how much was spent in this block. And so that's the idea. So we're going to say for transaction ID in every single one of the transactions, the transaction value will start at 0. Okay. Let's see, what does that make sense? So we have a block value starting at 0 because the block is the overall thing that's computed. Oh, okay, because the transaction value changes every single time that we get a new transaction, and then we just add that to the block value. All right, so then we get a raw transaction here, p.get raw transaction. So that's the thing that we just did earlier. Then we're going to need to decode it, and then from that decoding it, we can remember that from earlier, is that we can get the value. That's what happens there. So this is the decoded transaction, and we're just going to keep tacking on that value. And there's multiple outputs potentially, I guess, in a transaction. So that's also something to be aware of. Here, they're just going to add block value plus equals block value, and print total block value is that. So how much block value was spent? How much Bitcoin was spent in this block? It's going through, it's looping, using my Raspberry Pi's CPU. I wonder how long this takes. This can't take that long. Did I not press enter? All right, so we're gonna give that some time to run. While it's doing that, let's go take a look at a couple other books. So there's Programming Bitcoin, and then the last one that I'll definitely recommend is Mastering the Lightning Network. Now, I haven't read Programming Bitcoin or Mastering the Lightning Network yet, so I'm recommending them without reading them, but there isn't a lot of literature on the topic anyway. So I definitely recommend checking this out if you're interested in figuring out what's going on with the Lightning Network. And I would be interested because it's pretty game-changing stuff. As long as you're someone who's not a big blocker, this is kind of the direction, as far as I can tell, that we need to go. All right, and so now we have the value here. So total value in the block spent was 10,322 and point blah 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 Bitcoins, and that's basically it. All right, and so the last thing that he goes over in here is all the different clients, libraries, and toolkits. So there's lots of alternative clients, libraries, and toolkits, and even full node implementations in the Bitcoin ecosystem. These are implemented in a variety of programming languages, offering programmers native interfaces in their preferred language. Yeah, so you can interact with Bitcoin basically however you want. You can run your full node. I mean, probably you should run your full node using the core Bitcoin core implementation. That's what I would recommend, just because you likely want the same bugs as them, right? That most other nodes on the network are speaking, and most nodes on the network are speaking the C++ reference implementation. But yeah, so if we go over here, I don't know if he has this in this chapter, but we're gonna go into ASCII doc 3 and jump to the bottom here. Okay, and if you go to the bottom, you can see okay, this is the reference implementation. This is what I actually have installed on my Pi, and I'm running, and I'm using this to validate blocks and all. Right, so this is the reference implementation, and then that's Bitcoin D and all that kind of stuff. There's lib Bitcoin, so this is I guess it's also a node, a development toolkit. I don't know. Bitcoin Explorer, PicoCoin. It's kind of cool. It's written in C by Jeff Garzik. Yeah. Bcoin is in JavaScript, so this is actually a full node implementation in JavaScript, so if you really want to roll the dice with that. Bitcore, this is also, I guess, in JavaScript. Bitcoin.js, a pure JavaScript. Bitcoin library for Node.js and browsers. Right, so this is more of a library, more like what we did recently just now, probably just for interacting over JSON RPC. Java, PHP, Python. The one that we used was this one right here. Go, Rust, and I'm sure there's more, but these are the ones that are mentioned in the book. So yeah, it's something interesting to know. I feel like it's kind of a pitfall where you think Bitcoin is written in this language, and it can be written in any language, right? But don't really let that fool you, because basically you want to run this one. Likely you want to run the Bitcoin Core reference implementation for as long as it remains the reference implementation. All right, so that's basically it for this stream. I got through this chapter. The next chapter we're gonna go through is gonna be keys and addresses. So we're gonna be taking a look at private public key pairs. This is where the real crypto part comes, right? We're gonna be going into elliptic curve cryptography, how to generate a public key, how Bitcoin addresses are generated, base 58. Let's see. Looks like there's a little bit of C code we're going to get to write. And yeah. So this is a pretty long chapter, but this is a lot of the cryptography that secures the network. So it's pretty important. And the one after that will be wallets. So there's my phone. All right, so I will see you guys then. Hopefully I'll be able to do this stream tomorrow, but who knows. But yeah, just watch out for the streams, and I'll see you guys next time.